Good evening, dreamers. Tonight, as you settle into rest, let us take a journey together, not across oceans or deserts, but upward, into the vast silence of space. The stars above have always been there, waiting, glowing, flickering in their endless watch. But have you ever wondered when the very first human looked up and realized that the night sky was not just darkness, but a map, a mystery, and perhaps even a message? Close your eyes for a moment and imagine yourself tens of thousands of years ago. The world is quiet, untouched by the hum of electricity or the glow of neon. Nightfall is not interrupted by lamps or city lights. Only fire flickers nearby, and beyond its soft warmth stretches the unbroken dome of stars. For our earliest ancestors, the sky was both terrifying and comforting, filled with lights that seemed alive, yet impossibly far. The silence of space was not yet known, but the awe was the same as it is today. What did they think those lights were? Were they souls? Were they fires? Or were they gods? The truth is that we will never know exactly, yet through fragments of myth, carvings on stone, and even the careful alignment of ancient burial sites, we catch glimpses of the first stargazers, dreamers like you, but with no names left behind. Archaeologists believe that long before the first cities, humans already tracked the movement of stars. Some caves, such as the famous Lascaux in France, contain not only paintings of animals, but also dots and patterns that match constellations. Imagine a hunter crouching by the fire, scratching tiny marks to mimic the stars above, leaving behind a map not of the earth, but of the heavens. To them, the stars were both a mystery and a guide. The night sky told them when to travel, when to hunt, and when the seasons were about to change. In its silence, the universe was already speaking. Now, let's drift slowly toward Mesopotamia, the land between the rivers, where some of the earliest civilizations took shape. Around 5,000 years ago, the Sumerians were watching the same sky you see when you look up tonight. But unlike Uze, they did not yet call it astronomy. For them, the stars were divine messengers. Each planet, each wandering star, was linked to a god. Venus was Inanna, goddess of love and war. The moon was Nana, watching the night with silver light. The stars were not cold-burning suns in their view. They were the breath of the divine. And so, quietly, under the velvet night, priests climbed ziggurats, massive stepped temples, to keep watch. They carried clay tablets and pressed wedges into them, recording the rising and setting of stars. They had no telescopes, not even lenses, only their eyes and patience. Yet from this, they discovered patterns, the cycles of Venus, the predictable return of eclipses, the slow march of constellations. Imagine the dedication, night after night, for decades, for lifetimes, men watching, waiting, recording, and through them, humanity took its first careful step into astronomy. The silence of space still lingered. No one yet knew what stars really were, but they knew enough to predict, and prediction was power. Kings depended on these priests. Farmers trusted them to declare when floods would arrive. Armies feared or welcomed omens, drawn from eclipse. In a way, the stars governed Earth. And yet, beyond the myths and the rituals, imagine the private thoughts of a Sumerian boy lying on a rooftop. No tablets in his hand, no duties to a king, only his eyes gazing up. Did he wonder if the stars were countless fires, as eternal as the gods? Did he feel small beneath them, or safe? In Iberiera there are fisher records, but also quiet moments like this. Personal wonder, unrecorded but eternal. From Mesopotamia, let us drift eastward to Egypt. Along the Nile, the night sky was not only a curiosity, but a calendar. The Egyptians learned to watch for Sirius, the dog star. Its rising in the dawn sky marked the coming of the floods. Floods that would nourish the land and keep their civilization alive. Imagine lying in the desert night, the sand cool beneath you, waiting for that single star to appear. When it rose, hearts leapt with hope. Without Sirius, the Nile might not rise, and crops would wither. In the silence of the desert sky, Sirius became a promise of survival. But the Egyptians did more than watch. They built the pyramids. Those eternal mountains of stone were aligned with the heavens. Some of their shafts pointed directly towards stars like Orion's belt. The pharaohs wished to become stars themselves after death, to join the gods in the endless night. So when you look at the pyramids today, you are not only seeing stone, you are seeing a telescope of sorts, a monument built to connect Earth to the stars. Now, dreamers, pause with me. Think of how long humans have stared at the night sky. Tens of thousands of years. And yet, the stars themselves have barely changed. The same constellations that guided Mesopotamian priests, that comforted Egyptian farmers, shine above us tonight. They wait for you too, whenever you step outside and lift your eyes. And here lies the hook, the question that lingers like a whisper. If the stars have always been there, quiet and steady, what secrets have they been keeping? And why did humanity, across every continent, feel drawn to them, as if they were more than just lights in the dark? The silence of space is vast, dreamers, but it is not empty, and our journey through it has only just begun. Dreamers, let us move quietly across mountains and rivers, leaving the pyramids of Egypt behind. Imagine a slow wind carrying us east, over deserts and steppes, until we arrive in ancient China. Here too, long before telescopes, people tilted their heads back and listened to the silence of the stars. In China, the night sky was more than beauty. It was an empire above the empire, a heavenly mirror of the order below. The emperors were known as the sons of heaven, and so the heavens themselves were thought to echo and guide the fate of the earthly kingdom. If a comet blazed across the sky, it was not just an icy wanderer, it was a warning, a heavenly whisper of the sworder. Chinese astronomers were among the most meticulous in history. Over 2,000 years ago, they were already writing down records of eclipses, comets, and novae stars that appeared suddenly, flared brightly, and then faded away. Some of the earliest records of Halley's Comet come not from Europe, but from Chinese scholars, carefully noting its sudden arrival in the night. Imagine the patience of these observers, sitting on wooden platforms, ink in hand, candles flickering beside them, as they charted the movements of lights millions of miles away. But astronomy here was not only practical, it was also poetic. The constellations were not the same as those in the West. Instead of Orion, hunters, and lions, the Chinese sky was filled with different images. The azure dragon of the east, the white tiger of the west, the black tortoise of the north, and the vermilion bird of the south. Each star belonged to a story, a cosmic animal watching over its realm. Even the Milky Way was seen as a celestial river, the silver stream, across which a cow and a weaver girl to lovers could meet only once a year, on a bridge of magpies. So when the stars sparkled overhead, there were not only lights, but actors in a great play that stretched across the heavens. And dreamers, isn't that beautiful? The sky we call science today was once theater, once poetry, once the whisper of lovers. Perhaps that is why it feels so calming to gaze upward even now. Let us drift further, to India, where the heavens were also sacred. The ancient Vedic texts, written thousands of years ago, sang of the stars and their meanings. The Sanskrit word Jyotisha, the science of light, referred both to astronomy and astrology. For the thinkers of ancient India, the sky was both mathematics and myth. They studied the positions of the planets, the cycles of the moon, and the eclipses of the sun. But they also told stories. Stories of deities who chased across the sky, of demons who swallowed the moon, of cosmic oceans in which stars floated like shining islands. Indian astronomers gave the world great gifts. They worked out complex calculations of planetary movements, and even early estimates of the Earth's size. The great mathematician Aryabhata, living in the 5th century, wrote that the Earth spins on its axis, creating the illusion of the stars moving overhead. Imagine how radical this must have sounded, that the heavens were not spinning, but that we were. Yet he wrote it calmly, like a truth discovered in silence. But here too, beyond mathematics, the night sky was a place of reflection. The moon was worshipped as a deity, gentle and cool. The stars were seen as ancestors, distant but ever watching. To look upward was to be reminded of the vastness not only of the universe, but of time itself. Cycles of creation and destruction, stretching endlessly, with the stars as witnesses. Now, dreamers, let us pause for a moment. Picture yourself lying on soft grass, halfway between China and India, perhaps on a hillside where caravans once passed. The stars above are countless. To one traveler, they are dragons and tigers. To another, they are gods and demons. To a third, they are patterns of numbers and cycles. And to you, lying there, they are simply a blanket of calm light, endless and quiet, pulling your thoughts into stillness. Every culture, every age, every human heart has asked the same question: what is out there? And in the silence of space, each found an answer that soothed, that guided, that gave meaning. But dreamers, this is only the beginning, for soon the Greeks will rise, with philosophers who dared to ask whether the earth itself might be a sphere, floating in nothingness. And later, The Islamic Golden Age would bring scholars who preserved and expanded the wisdom of all these lands, gazing upward with instruments more precise than any before. The silence of space is long, but human curiosity is longer still. Dreamers, let us float westward now, across seas and islands, into the world of ancient Greece. Here, the night sky still glittered with gods and myths, yet slowly, quietly, another way of thinking was taking shape. The Greeks looked upward, and for the first time, some of them dared to say, perhaps these stars are not gods at all. Perhaps they are things fiery, distant, yet knowable. Imagine Athens. On a warm night, the air carrying the smell of olive trees, the streets lit only by oil lamps. Above, constellations glimmer. Too many there are still stories: Orion, the hunter, chasing the Pleiades, the seven sisters who run forever across the sky. But to the philosophers, those strange, thoughtful men who questioned everything, the stars were not only stories, they were puzzles. One of the earliest thinkers, Thales of Miletus, around 600 BCE, was said to have predicted a solar eclipse. To us, that seems simple, for we have computers and formulas. But to predict the darkening of the sun 2,500 years ago, that was extraordinary. For the people who watched the sky darken in midday, it must have felt like magic. Yet Thales claimed it was not magic, but knowledge. The heavens could be studied, and then came Pythagoras, who listened to the stars in a way unlike anyone else. He believed that the entire universe was harmony, that these stars and planets moved according to mathematical music, the music of the spheres, though we could not hear it. To him, the heavens were like a great harp, strummed silently across the night. Imagine lying beneath the stars and believing that each glittering light was part of a cosmic song too vast for human ears. Isn't that a calming thought, dreamers, that we sleep within a quiet symphony? Later came Anaxagoras, who said boldly that the sun was not a god, but a fiery stone, larger than the Peloponnesus itself. For saying such things, he was nearly executed. Yet his idea lingered. Slowly, people began to see the heavens not only as a stage for myths, but as a place made of matter, governed by laws. And then came Plato and Aristotle, whose names you may know well. They, too, gazed upward. Plato imagined the heavens as perfect, a realm of eternal circles where planets moved in unchanging harmony. For him, the heavens were more perfect than earth, and their order was proof of higher truth. Aristotle agreed, but he was more practical. He taught that the earth sat at the center of the universe, unmoving, while the sun, moon, planets, and stars circled around it in great crystal spheres. This idea, the geocentric model, would last for nearly 2,000 years. Imagine that, dreamers. For centuries upon centuries, people believed we were at the very center of everything, but not all agreed. Far to the north, in Samos, lived a man named Quietly, against all tradition, he suggested something radical. What if the earth moved around the sun, instead of the other way around? His idea was largely ignored, like a whisper in the wind. Yet that whisper would one day grow into the roar of the Copernican revolution. For now, it was just a thought, a fragile seed planted in the silence of space. The Greeks gave us another gift: geometry applied to the sky. Hipparchus, one of the greatest astronomers of antiquity, measured the brightness of stars and created one of the first star catalogs. He also noticed something strange. The stars were shifting, ever so slightly, over centuries. This was the discovery of the precession of the equinoxes, the slow wobble of Earth's axis. Imagine the patience it required to notice such a slow movement, the kind that takes hundreds of years to reveal itself. Yet Hipparchus saw it, and then came Ptolemy, in Alexandria, who gathered centuries of Greek thought into one great work, the Almagest. His vision of a universe with Earth at the center, surrounded by perfect circles, became the textbook of the heavens for more than a millennium. It was not correct, but it was orderly, and in that order, people found comfort to look at the stars and believe they moved in perfect harmony around us. It was a soothing vision, one that matched the longing of humans for stability in an uncertain world. Now, dreamers, picture a Greek philosopher lying back on cool stone, gazing upward. Around him, students debate. Some speak of gods, others of geometry. The stars are no less mysterious than they were in Mesopotamia or Egypt, yet the Greeks have given them something new. The idea that the heavens can be understood not only by myth, but by reason. And yet, in the silence of space, no answers are final. For what is reason but another way of wondering, another kind of dream? Soon, we will drift further into the deserts and cities of the Islamic Golden Age. There, scholars will take the wisdom of Greece, preserve it, and refine it with new instruments, new mathematics, and a new devotion to the sky. Dreamers, let us leave the marble courtyards of Greece behind and drift eastward once again. The centuries have turned. The Roman Empire has risen and fallen. The ancient knowledge of Greece and India could have vanished into silence, but it did not. For in the cities of the Islamic world, in Baghdad, Damascus, Cairo, Samarkand, Cordoba, the stars still shone, and people still watched. The Abbasid caliphs of Baghdad, around the 8th and 9th centuries, believed deeply in knowledge. They built the great house of wisdom, Beit-o-Hikmah, a place where scholars gathered, not only from the Islamic lands, but from Greece, India, and Persia. Here, old manuscripts were translated into Arabic, Ptolemy's Al-Majis, the Vedic texts, Aristotle's writings, all were preserved, and studied under the warm glow of oil lamps. The night sky became a shared inheritance of humanity. Imagine stepping into Baghdad at night during this age. The Tigris River flows quietly, lanterns line the streets, and above it all, the stars shimmer. In one corner of the city, scholars bend over tables, drawing diagrams of planetary paths. They debate over the geometry of the heavens. Their work is not only study for its own sake, it is also practical. Prayer times depend on the position of the sun. The direction of Mecca, the Qibla, must be calculated. Calendars, navigation, and even architecture require astronomy. The sky, in silence, serves life below. Among these scholars was Al-Battani, known in the West as Patiently, he refined the measurements of the Greeks. He studied the length of the year, the tilt of Earth's axis, and the motion of the moon. His tables of planetary motion became so accurate that they were still used centuries later by Copernicus in Europe. Imagine his quiet nights of observation, no telescopes, only the naked eye, yet with enough discipline to chart the heavens with a precision that endured for ages. Then came Al-Sufi, the Persian astronomer, who wrote the Book of Fixed Stars. In its pages, he described constellations not only as the Greeks had seen them, but as they were known in Persian tradition. He also recorded the brightness of stars, and even described a faint cloud in the constellation Andromeda, what we now know to be the Andromeda Galaxy, the nearest great galaxy to our own. Think of that. Dreamers. Over 1,000 years ago, a man in Persia quietly noted the presence of another world of stars, far beyond our own Milky Way. Further east, in Samarkand, a city that glittered on the Silk Road, another wonder arose. The observatory of Ulugh Beg, a Timurid prince who loved the stars more than power. In the 15th century, he built one of the largest instruments ever made, a massive carved into stone, stretching across his observatory. With it, he and his team measured the positions of over 1,000 stars. Even centuries later, their catalogue remained astonishingly accurate. Picture the silence of those desert nights. The observatory open to the heavens, the prince himself standing under the vast dome of stars, more devoted to their quiet truth than to conquest. But perhaps the most beautiful gift of the Islamic Golden Age was not just measurements, but preservation. Without the translators and scholars of Baghdad, Cordoba, and Cairo, much of Greek astronomy would have been lost forever. When Europe entered the Middle Ages, many of these Arabic texts would return, sparking a revival of learning. In this way, the stars were carried like lanterns across civilizations, never fully extinguished. Dreamers, imagine how humanity has always guarded the night sky, like a flame passed from hand to hand. The Sumerians watched it, the Egyptians aligned their monuments to it, the Greeks tried to explain it, and the scholars of the Islamic Golden Age measured it with care. The silence of space remained, yet within it, a chorus of human voices grew, each adding a note of understanding. And still, mysteries lingered. What truly were the planets? Why did their paths sometimes loop backward in the sky? Could Earth really be at the center, as Ptolemy said? Or was there another truth hidden in the silence? These questions would wait for another age, the Renaissance in Europe, when thinkers like Copernicus, Galileo, and Kepler would dare to turn the universe inside out. Dreamers. Let us move gently into Europe, into the 15th and 16th centuries. The Middle Ages are giving way to the Renaissance. Old manuscripts, many preserved by the scholars of the Islamic Golden Age, are returning to Europe. Printing presses spread knowledge faster than ever before. Painters study light, sculptors carve marble, and thinkers turn their eyes upward once again. For centuries, Ptolemy's model of the heavens had ruled unquestioned. Earth at the center, stars and planets moving around it in perfect circles. It was comforting, orderly, and familiar. But sometimes, dreamers, the silence of space whispers truths that unsettle us. In Poland, there lived a man named Nicolaus Copernicus. Quiet, cautious, more scholar than revolutionary. He spent decades working in secrecy, for his idea was daring. What if Earth was not at the center at all? What if the sun stood at the center, and we, along with the planets, circled around it? To Copernicus, this heliocentric vision explained the odd loops of the planets in the sky, their retrograde motion. It made sense of the heavens in a new, elegant way. But it also challenged centuries of belief. Imagine the courage it took to write those words, to suggest that humanity was not at the middle of creation, but on a moving world, a traveler through space. When his book on the revolutions of the heavenly spheres was finally published in 1543, the world quietly shifted. The silence of space grew louder, more mysterious. After Copernicus came Tycho Brahe, a Danish nobleman with a golden nose, a replacement for the one he lost in a duel. He built an observatory on the island of Hven, filled with the finest instruments of his time. Night after night, he and his assistants measured the heavens without telescopes, only with their precise tools and patient eyes. His records of Mars would later give Johannes Kepler the key to unlock the laws of planetary motion. Kepler, gentle yet determined, discovered that the planets did not move in perfect circles, but in ellipses, stretched, oval paths around the sun. Imagine his wonder as he realized that the universe was not built on divine perfection, but on hidden mathematics. Planets moved faster when near the sun, slower when far away. The heavens were not a stage of flawless circles, but a dance of curves and rhythms, and Kepler heard in that dance a kind of cosmic music, echoing the Pythagorean dream from long ago. And then, dreamers, came Galileo. With trembling hands, he lifted to the sky a new invention. The telescope. At first, it was a toy for merchants, used to see ships on the horizon. But Galileo turned it upward, and the silence of space broke open. Through his lens, he saw mountains and valleys on the moon, proving it was not a perfect sphere, but a world of its own. He saw 4 tiny moons circling Jupiter, like miniature planets, proof that not everything revolved around Earth. He looked at Venus and watched its phases, just like the moons, showing that it orbited the sun. And when he turned his telescope to the Milky Way, he gasped. The hazy band across the night was not a cloud at all, but countless stars, too faint to see with the naked eye. The universe was deeper, richer, and more crowded than anyone had imagined. But with wonder came danger. Galileo's discoveries challenged the teachings of the Church, for saying that Earth moved, that the heavens were not as the ancients described. He was tried, silenced, and placed under house arrest. Yet his words remained a pur si move, and yet it moves. Dreamers, imagine lying in an Italian garden, a telescope beside you, the stars above. The silence of space is no longer empty. It is full of worlds, full of possibilities. The Earth is not the center. We are moving, turning, spinning through a vastness that suddenly feels both humbling and thrilling. The Renaissance had changed the heavens forever. But the silence of space still held secrets, secrets that Isaac Newton, with his quiet mind, would soon unravel into laws that bound apples to Earth and planets to the sun. Dreamers, let us linger now in the late 17th century, a time of quiet gardens, flickering candlelight, and restless minds. The telescope has already revealed mountains on the moon, moons around Jupiter, and stars beyond counting. But one question remains, soft and heavy, hanging in the silence of space. What holds it all together? In England, there lived a man named Isaac Newton. He was shy, often solitary, sometimes quick to anger, but his mind was vast, precise, and endlessly curious. Imagine him sitting beneath an apple tree in his garden at Woolsthorpe Manor. The story is famous. An apple falls, striking the ground. Others might laugh, or take no notice at all. But Newton's thoughts drift differently. He wonders, does the same force that pulls the apple down also pull the moon, keeping it in its endless path around Earth? Out of such musings grew one of the most profound ideas in history. Gravity, an invisible thread, universal and constant, binding Earth and sky alike. To Newton, the heavens were no longer separate, no longer divine and unreachable. The same laws that ruled falling apples ruled the planets and the stars. The silence of space was not chaos. It was order, hidden and beautiful. Newton's great book, the Principia Mathematica, published in 1687, described this order. With the laws of motion and the law of universal gravitation, He gave the universe a kind of language. Imagine, dreamers, the boldness of this vision, that with mathematics alone, one could describe the arcs of comets, the dance of moons, the tides of oceans. The universe could be known, predicted, measured as if the silence of space had become a song written in numbers. But Newton's genius did not stop at gravity. With prisms, he showed that white light could be split into colors, revealing that the rainbow lived inside every ray of sunlight. He built telescopes that used mirrors instead of lenses, sharper and clearer than ever before. And he reminded the world that knowledge was not given by gods or rulers, but earned by patient observation and thought. Yet even Newton, dreamers, knew that the silence was not fully broken. He confessed that he felt like a child playing on the shore, while the great ocean of truth lay undiscovered before him. Imagine him in his later years, walking alone in his garden, looking upward at the stars, knowing he had uncovered one secret, but aware that countless more remained. Newton's work changed the world. For the first time, humanity felt it could understand the cosmos, not through myth, not through faith alone, but through universal laws. The planets were not wandering gods, but worlds obeying the same pull that draws us gently down to earth. And yet, dreamers, in the stillness of the night sky, mysteries lingered. What were the stars themselves? Were they distant suns? Did they have worlds around them, like our Earth? And what of the strange new objects appearing in telescopes? Comets, nebulas, faint patches of light. Were they within our galaxy, or beyond? The silence of space seemed deeper than ever, and now humanity had sharper tools to listen. Soon, astronomers would build greater telescopes, powerful enough to pierce the dark, and reveal that the universe was far larger than Newton, or anyone before him, could have imagined. Dreamers. The 18th century was an age of quiet revolution in the heavens. Newton had given the universe its invisible laws, but now astronomers sought to explore the sky more deeply, to map its countless lights and measure its unfathomable distances. The silence of space was vast, but humanity was learning to listen more closely. Let us begin with a man named Edmund Halley. You may know his name, tied forever to a comet that streaks across our skies every 70 SX years. But Halley was more than a name in the stars. He studied the orbits of comets, discovering that one recorded in ancient texts was the very same that returned in his own time. It was a revelation. Comets were not random visitors, but loyal travelers, bound by gravity, circling the sun in long, slow arcs. Imagine the awe of knowing that a comet seen by Babylonian priests was the same one you could watch blaze across your own night sky. Halley's prediction gave humanity its first glimpse of time measured not in years or centuries, but in the patient rhythms of space. Then came William Herschel, a German-born musician turned astronomer in England. With his sister Caroline at his side, he built telescopes taller than houses, their mirrors polished by his own hands. Through them, he searched the heavens with tireless devotion. One night, in 1781, Herschel saw something no one had seen before. A planet beyond Saturn, moving slowly against the fixed stars. It was Uranus, the first new planet discovered in human history. Imagine the wonder of that moment, to realize the solar system was larger than anyone had dreamed, and that perhaps there were more worlds still waiting in the silence. Caroline Herschel, too, made her mark. Night after night, she swept the skies, discovering comets and cataloging stars. Picture her, a woman in an era when few women entered science, yet working side by side with her brother, her eyes steady at the telescope, her heart filled with the quiet joy of discovering. The Herschel showed the world that the heavens were not static, but full of surprises. But William Herschel's greatest gift may have been his attempt to map the Milky Way. Patiently, he counted stars in every direction, trying to measure the shape of our galaxy. His sketch, though imperfect, revealed that the Milky Way was not just a band of stars, but a vast system, and that our sun was only one among billions. Dreamers, think of how humbling that must have been, to know that Earth was not at the center of all things, nor even our sun. We were drifting in a sea of stars, a single spark among countless others. Across Europe, other astronomers joined in this work. Charles Messier, in France, searched the skies for comets, but kept stumbling upon faint, fuzzy patches of light objects that did not move like comets, but remained fixed among the stars. He catalogued them carefully, from the great Orion Nebula to the distant Andromeda Nebula. To Messier, they were nuisances, distractions from comet hunting. But to later generations, they would become gateways to new worlds, galaxies, and star clusters far beyond our own. Now imagine yourself, dreamer, standing in a quiet field in the late 18th century. Beside you is a telescope, It's mere cold to the touch. Above, the Milky Way spills across the night, a river of stars. As you peer through the glass, faint smudges appear, too dim for naked eyes. They are not clouds, not tricks of vision, but real places, other systems of suns, hanging silently in the darkness. You realize then that the universe is not only vast, it is endless. The silence of space, once filled with gods and myths, now became filled with questions. How many stars are there? How many worlds? Are we alone in this sea of light? The answers would come slowly, with larger telescopes, better instruments, and new mathematics. And soon, in the 19th century, humanity would learn to break the light itself into colors, to read in starlight the chemistry of the universe. Dreamers, imagine for a moment standing beneath the night sky as countless generations have before you. The stars above are steady, silent, eternal. For millennia, humanity wondered, what are these points of light? Are they distant suns? Are they made of the same matter as Earth? Or are they of some other, heavenly substance? The question lingered like a soft whisper in the silence of space. In the early 19th century, a new way of listening to starlight began. Scientists learned that light itself could be unraveled, past sunlight through a narrow slit and a prism. And instead of a single beam, you see a rainbow, a spectrum. But this rainbow was not smooth. It was marked with thin, dark lines, like scratches across its glow. These mysterious lines were first carefully recorded by a German optician named Joseph von F. He built precise instruments, prisms, and lenses, and he charted hundreds of these spectral lines in sunlight. He did not know their meaning, but he sensed they were a key, a message written into the light itself. Years later, others found the answer. The dark lines were fingerprints, dreamers, signs of elements absorbing specific wavelengths of light when heated. Every element, whether hydrogen, sodium, or iron, gives off light of certain colors. When those same elements lie in the atmosphere of the sun or stars, they absorb those same colors, leaving shadows in the spectrum. By studying these patterns, astronomers realized they could read the composition of stars from across the void. It was a revelation as great as Newton's gravity. For the first time, humanity could say with certainty, the stars are made of the same elements as Earth: hydrogen, helium, iron, calcium. The very building blocks we know here below are the same that burn in the heavens. The barrier between Earth and sky had dissolved even further. The silence of space was no longer unknowable. It could be studied, decoded, spoken. Dreamers, picture the quiet excitement of those nights in observatories, where astronomers placed prisms before their telescopes, letting starlight scatter into rainbows. Each rainbow became a sentence, each line a word, telling of temperature, pressure, and substance. Stars, once only distant lights, became fiery laboratories, their secrets revealed in color. And with this new science of spectroscopy, the cosmos grew stranger still. So many nebulae, once thought to be clouds of faint light, showed spectra that suggested glowing gases, vast clouds of hydrogen and other elements, floating in interstellar space. Others, like the Andromeda Nebula, showed spectra resembling those of stars, hinting they might be distant galaxies, each filled with suns. The silence was deep, but within it were layers upon layers of voices waiting to be heard. By the late 19th century, astronomers such as William Huggins in England were pioneering this field. Huggins pointed his telescope toward stars and nebulae, passing their light through prisms, and revealed the chemical kinship of the universe. His work showed that space was not alien, not made of divine fire, but of the same elements found in earthly laboratories. The universe was kin to us, and dreamers. There was something poetic in this discovery, to look at a star thousands of light years away and know, without touching, without traveling, that it was burning hydrogen into helium, just as our own sun does. The stars were not unreachable after all. They were family, distant, but familiar. As the 19th century drew to a close, astronomers held new tools: the telescope to see, mathematics to describe, and now spectroscopy to understand. But there was still one mystery. How did stars shine for so long? The fires of earthly combustion could not last for millions, let alone billions, of years. What power fueled the suns? That secret, dreamers would wait until the 20th century, when physics would unlock the heart of the atom itself. For now, the silence of space had been transformed into a song written in light, deciphered by prisms and patience, and humanity had learned to read the stars. Dreamers, The 19th century had given humanity the rainbow language of stars. But the 20th century began with a new ambition: to see farther, to measure deeper, to ask not just what stars are made of, but how far they lie, and how vast the universe truly is. Atop lonely mountains, where the air was thin and still, new observatories rose, great domes of silver and steel, housing telescopes larger than the world had ever known, opened their eyes to the heavens. Picture the Great Refractor at Yoki's Observatory in 1897. Its enormous lens stretching 40 inches across. Or soon after, on Mount Wilson, in California, the building of the 60-inch, and then the 100-inch Hooker telescope, the most powerful in the world. It was through this latter telescope that the universe would whisper one of its greatest secrets. But before we reach that moment, let us pause with the astronomers who climbed nightly into those domes. Wrapped in coats against the cold mountain winds, they leaned over guiding the heavy machines by hand, sometimes for hours. Each photograph of the sky required patience. Glass plates coated with chemicals, exposed for long minutes or even hours, recording faint stars invisible to the eye. Among these early pioneers was Henrietta Swan-Leavitt, a quiet figure at Harvard College Observatory. She worked as one of the computers women employed to study photographic plates of stars. Patiently, she examined variable stars, those whose brightness waxed and waned over time. In 1908 she discovered something extraordinary: a pattern between the brightness of a certain kind of star, called Cepheid variables, and the time it took them to vary. This relation became a cosmic yardstick. By measuring a Cepheid's flicker, one could calculate its true brightness and thus its distance. Leavitt, though underpaid and little recognized in her lifetime, had given astronomy its first reliable ruler for the universe. Dreamers, imagine the power of that. For centuries, the stars had been beyond all measure, their distances unknowable. Now, with Leavitt's discovery, the darkness had coordinates. The silence of space could be charted. It was this tool that, a decade later, another astronomer would use to reveal the vastness of the cosmos. His name was Edwin Hubble. Working at Mount Wilson with the 100-inch Hooker telescope, Hubble studied the faint, fuzzy nebulae that Messier had catalogued centuries before. Were they clouds of gas within our own galaxy, or island universes' galaxies in their own right, far beyond? In 1924, by identifying Cepheid variables within the Andromeda Nebula, Hubble proved it lay far outside the Milky Way. Dreamers. This was a moment that forever changed humanity's place in the universe. The Milky Way was not the universe entire, but only one galaxy among countless others. The silence of space had stretched beyond imagining into a realm of billions of galaxies, each filled with billions of stars. And Hubble's revelations did not end there. By studying the light of distant galaxies, he noticed something subtle. Their spectra were shifted toward the red end, stretched as if by motion. With careful analysis, he discovered that the farther a galaxy lay, the faster it seemed to be rushing away. The universe, dreamers, was not static. It was expanding. This quiet but earth-shaking truth meant that the cosmos itself had a beginning, a moment when space and time burst forth. The silence was not eternal. After all, it had a dawn. This idea, the seed of the Big Bang Theory, would grow and reshape science and philosophy alike. But pause here, dreamer, and imagine yourself at Mount Wilson in the 1920s. The Great Dome is cold and silent. The telescope a dark giant pointing skyward. At the eyepiece, you trace faint smudges of light. You realize each one is a galaxy, vast beyond thought, and that all are drifting apart, carried on a current of expanding space. The silence of the night suddenly feels even deeper, yet filled with a quiet hum of creation. The 20th century would become the golden age of astronomy: radio telescopes, space probes, satellites, and theories that stretched imagination itself. But before those marvels, it was the patient eyes at glass plates, the lonely watchers in mountaintop domes, who first cracked open the universe. Dreamers. For centuries, people had wondered what stars truly were. Through telescopes, they grew brighter. Through prisms, they revealed their elements. But still, one great mystery remained. What gave them their light? How could they burn for millions, perhaps billions of years, without fading to darkness? By the early 20th century, astronomers had new allies: physics and chemistry. The discovery of the atom and the strange powers hidden within its heart provided the missing clue. Stars, it turned out, were not burning wood, nor oil, nor anything so ordinary. Their power came from the very fabric of matter itself. At the core of a star, where gravity presses with unimaginable force, hydrogen atoms are pushed together. They fuse, becoming helium, and in the process, release tremendous energy. This is nuclear fusion, the secret engine of the stars. Each second, our sun converts millions of tons of hydrogen into light and heat, a steady glow that warms Earth and makes life possible. Imagine, dreamer, the comfort of knowing that the sunlight on your face is born of atoms, binding together in silence, deep within a star's heart. This understanding transformed astronomy. Stars were not eternal. They were living things, with life cycles shaped by their size. Small stars burned slowly, lasting billions of years, their light gentle and steady. Larger stars burned furiously, exhausting their fuel quickly, and ending in brilliant, violent deaths. Consider a massive star, many times the sun's size. For millions of years, it fuses hydrogen, then helium, then heavier elements, building up layers like an onion. But when it reaches iron, its heart can no longer yield energy. Gravity takes over. In a sudden collapse, the core shrinks, and the outer layers explode outward in a cataclysm, a supernova. For a brief moment, that star can outshine an entire galaxy. Imagine the silence of space torn by such brilliance, a beacon flashing across the cosmos. From these explosions, dreamers, come the elements of life itself. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were forged in the furnaces of dying stars. We are, in the most literal sense, made of stardust. The silence of space has given birth, not only to light, but to us. And when the explosion fades, sometimes a dense remnant remains, a neutron star, so compact that a teaspoon of it would weigh as much as a mountain. Or, if the star was massive enough, it collapses beyond even that, forming a black hole, an abyss from which not even light can escape. These are among the universe's strangest and most silent creatures, hidden in the dark, warping space and time itself. Yet not all stars end violently. Stars like our sun, gentler and smaller, swell into red giants, shedding their outer layers in drifting clouds of gas. What remains is a white dwarf, a hot ember cooling slowly over billions of years. Ebony death stars whisper softly, glowing faintly until they fade. By the mid-20th century, astronomers like Hans Bethe had worked out the mathematics of fusion, showing how stars shine. Telescopes confirmed these theories, and suddenly the stars were no longer eternal mysteries, but living, dying companions, each following the quiet rhythm of cosmic time. Dreamers, think of the serenity of this truth. When you look at the night sky, you are seeing stars in every stage of life, newborns and stellar nerds, steady middle-aged suns, and elders nearing their end. The silence of space is a cradle and a grave, endlessly renewing itself. And yet, knowing all this, new questions arose. How many stars fill the universe? How many galaxies? And among them, could there be planets, other Earths, other homes, perhaps even other dreamers gazing back at us? Dreamers, when Edwin Hubble revealed that the Andromeda Nebula was a galaxy beyond our own, he did more than double the size of the universe. He multiplied it beyond comprehension. Suddenly, the Milky Way was not the universe entire, but just one among countless galaxies scattered through the silence of space. Each one a vast congregation of suns, billions or even trillions strong. Picture a galaxy, a luminous disk, tens of thousands of light years across, its stars sweeping in graceful spirals or clustered in glowing ellipses. Between them lie vast clouds of gas and dust, nurseries where new stars are born. At this center, often, lies a dark secret, a supermassive black hole, millions of times the mass of our sun, quietly shaping the motion of all around it. Our own galaxy, the Milky Way, is such a place. From Earth, we see it only edgy on, a glowing band across the sky. But if you could rise above it, dreamer, you would see a great spiral, with arms curling outward, studded with stars and nebulae. The Milky Way holds perhaps 100 billion stars, and likely even more planets. Among them lies our sun, circling the galactic center once every 225 million years. Imagine that. Every time Earth completes one galactic orbit, entire ages of life have risen and fallen. In the 20th century, astronomers began to classify galaxies, like naturalists cataloging new species. Spirals, like our own, graceful and rich in gas and starbirth. Ellipticals, smooth and ancient, filled with older stars, their youthful gas long gone. And irregulars, chaotic in form, perhaps shaped by collisions with neighbors. Four galaxies are not still. They drift and dance, sometimes colliding in slow, silent embraces that last millions of years. Imagine two galaxies meeting, their stars passing mostly unharmed, yet their gas clouds colliding, igniting storms of star formation. Over time, their spirals may merge into a single, larger galaxy. Even now, the Andromeda Galaxy is on a slow collision course with our own. Billions of years from now, the two will merge into a new, larger galaxy, their stars mingling in a cosmic waltz. But galaxies are not isolated. They gather in clusters, great families of hundreds or thousands bound by gravity. These clusters form filaments and walls, the scaffolding of the cosmos, with immense voids between them. On the grandest scale, the universe resembles a web, a lattice of light and emptiness. The silence of space, when seen in this way, is not empty at all, but patterned, structured, alive. And galaxies themselves evolve. Some, rich in gas, glitter with young blue stars, like cities bustling with youth. Others, aged and red, glow more quietly, their days of star birth largely over. Black holes at their centers flare as quasars, bright enough to outshine entire galaxies, feeding on gas and dust with insatiable hunger. These, too, are part of the story. Galaxies as dynamic, changing entities, not eternal, but alive in cosmic time. Dreamers, consider the humility of this knowledge. Our world is one planet circling one star, in one arm of one galaxy, among billions. And yet, here we are, able to see and to wonder, to chart the silence with instruments of glass and metal. By the late 20th century, powerful telescopes in space, like the Hubble Space Telescope, would give us breathtaking images of galaxies far beyond reach. Spirals glowing like pinwheels, ellipticals like soft halos, clusters like jeweled constellations, each image a reminder of how vast and varied the universe is. And still, questions lingered. How are galaxies held together? What unseen matter keeps their stars from flying apart? And what force drives the universe to expand faster and faster? These mysteries would lead us deeper into the 20th century, into discoveries of dark matter and dark energy, the unseen fabric and breath of the cosmos. Dreamers, by the mid-20th century, astronomers had mapped galaxies and traced the expansion of the universe. Yet the deeper they looked, the more unsettling the silence of space became. For it seemed that what we could see, the stars, the gas, the shining galaxies, was not the whole story. In fact, it was only a small part. The first clue came from how galaxies moved. When astronomers measured the rotation of galaxies, they expected the outer stars to drift more slowly, as planets do around the sun. But instead, the stars at the edges moved just as swiftly as those near the center. Something unseen was holding them together, exerting gravity beyond what the visible matter could provide. This invisible mass was called dark matter. Imagine, dreamer, looking at a spiral galaxy, its arms of stars, glittering like diamonds, and realizing that what you see is only the tip of the iceberg. Surrounding it is a vast halo of dark matter, unseen, silent, yet outweighing the stars themselves. By some estimates, dark matter makes up 5 times as much mass as all visible matter in the universe. Without it, galaxies would unravel, their stars drifting apart into the void. And dark matter was not the only mystery. In the late 20th century, astronomers using supernova as distance markers made a shocking discovery. The expansion of the universe was not slowing, as gravity should demand. It was speeding up. Some unknown force was pushing galaxies apart with increasing energy. They called it dark energy. Dreamers, imagine the strangeness of this truth. The silence of space, vast and deep, is filled with an invisible pressure, stretching the cosmos ever faster. Where once we thought the universe might collapse back upon itself in time, we now know it may expand forever, galaxies drifting apart until their light can no longer reach one another. The universe, it seems, is growing lonelier with each passing age. Together, dark matter and dark energy make up about 95% of the cosmos. Everything we know, every star, every planet, every atom of our bodies, is part of the remaining 5%. In a sense, we live on islands of light in a sea of shadow, guided by forces we cannot see and do not yet fully understand. And yet, dreamers, there is something deeply soothing in this mystery, for the silence of space is not emptiness, but fullness filled with unseen matter and hidden energy, woven into the fabric of existence. To lie beneath the stars is to rest upon an ocean whose depths we have barely begun to measure. Even now, scientists build instruments to listen more closely. Deep underground, detectors wait in silence for a passing particle of dark matter. In the vast deserts and mountaintops, Telescopes scan the heavens for faint signs of dark energy's hand. And though the silence keeps its secrets well, each whisper draws us nearer. Think of it, dreamers. The stars above us are not the whole sky, but only a thin veil over a universe far stranger, richer, and more mysterious than we can yet imagine. And so the story of astronomy enters its most profound chapter 1, where the known and unknown blend, where every answer leads to deeper wonder. Dreamers. For most of human history, the sky was a ceiling, beautiful, mysterious, but unreachable. Then, in the 20th century, engines of fire and steel broke through that barrier. The silence of space, once only observed, became a place to be entered. It began in 1957, when a small sphere of metal called Sputnik was launched by the Soviet Union. It was no larger than a beach ball, yet it carried with it a weight as vast as history. As it circled the Earth, its faint radio beeps drifted down, the first artificial voice from beyond our world. Humanity had placed its hand on the stars. Soon after came living travelers. Leica, a small dog, became the first creature to orbit Earth, carried into silence aboard Sputnik 2. Her voyage was brief, yet it marked the beginning of a new age, when life itself ventured beyond Earth's cell shelter. Then, in 1961, came Yuri Gagarin, the first human to ride a rocket into orbit. Imagine his view, dreamer. Earth rolling beneath him, in shades of blue and white, the curve of the planet delicate against the darkness. Icy Earth. He is said to have declared, "It is beautiful in that moment." The silence of space was no longer just mystery. It was a destination. The years that followed became a race of nations, but also a triumph of human spirit. The United States and the Soviet Union pushed farther and faster, building rockets, testing capsules, sending astronauts and cosmonauts into the void. And then, in 1969, humanity made its first footprint on another world. Picture Neil Armstrong stepping down from the ladder of the lunar module, his boot pressing softly into the dust of the moon. That's one small step for man, one giant leap for mankind. Dreamers, pause with that image. A fragile human figure standing in the silence, looking back at Earth hanging like a jewel in the sky. For the first time, we became not just watchers of the heavens, but wanderers in them. The Apollo missions carried more explorers, who walked, drove, and worked on the lunar surface. They brought back rocks that told stories of the moon's ancient birth. And though those journeys ended, they left a vision that one day humanity might travel farther still. In the decades that followed, space exploration turned outward. Robotic probes ventured across the solar system. The Voyagers, launched in 1977, carried golden records of Earth's sounds and greetings, sailing past Jupiter, Saturn, Uranus, Neptune, and now into interstellar space, still whispering faint signals back to us. They are humanity's silent messengers, drifting beyond the reach of the sun's light. Closer to home, space shuttles carried astronauts to orbit again and again, building the International Space Station, a laboratory and home circling high above Earth. There, humans live and work in microgravity. Their daily routines, a quiet harmony with the vast silence outside their windows. Dreamers. Imagine being one of them. You wake to a sunrise every 90 minutes. The Earth rolling beneath you in oceans and deserts, clouds swirling like paint. At night, you drift by windows to watch auroras flicker over the poles, lightning flash in storms, and the Milky Way spill across the dark. The silence outside is endless, yet you are cradled within it, part of it. Space exploration has not ended. New telescopes, new rockets, and new dreams point us toward Mars, asteroids, and beyond. Perhaps one day, future dreamers will look back on Earth from even greater distances, whispering to themselves in awe at how small, how precious their home appears. The silence of space is no longer unreachable. We have touched it, entered it, lived within it, and in doing so, we have changed not only our knowledge, but our perspective. From space, Earth is a single world, fragile and beautiful, shared by all who dwell upon it. Dreamers, if you close your eyes for a moment, you may feel what countless generations have felt when looking at the stars. Not simply curiosity, but wonder, awe, and even comfort. For long before space was reached with machines, it was entered with poetry, painting, and music. Consider how ancient storytellers once spun constellations into myths. Orion was not just a cluster of stars, but a hunter forever chasing across the sky. Cassiopeia was not only a crooked W, but a queen, punished for her vanity. Through such stories, People placed pieces of themselves in the heavens, making the silence feel familiar. Artists, too, have always reached upward. Look at Van Gogh's Starry Night. Swirls of paint turned the night sky into a living sea of light, not distant, but flowing, breathing, alive. In his Breathtaking, the stars whisper, not with silence, but with movement. Musicians have also lifted their notes into the sky. Gustav Holst composed the planets, each movement a reflection of celestial moods. Mars, the bringer of war. Venus, the bringer of peace. Jupiter, the bringer of jollity. Though no planet plays such music in reality, the silence of space inspired harmonies here on Earth, echoing in concert halls as if the heavens themselves had a voice. And then there are the poets. From Shakespeare's lines, "The fault, dear Brutus, is not in our stars, but in ourselves," to modern verses that liken stars to lanterns, seeds, or distant friends. Words have carried starlight into human hearts. Poets remind us that, while science explains, art connects. Even today, when we know the stars are burning spheres of plasma, their light millions of years old, they still inspire metaphor. Two lovers, stars are promises. Two dreamers, they are destinations. To those who grieve, they are reminders that something shines beyond the darkness. Consider how astronauts themselves, those who have truly left Earth, often speak not in calculations, but in poetry. They describe Earth as fragile, delicate, like a blue marble against blackness. They return not just with data, but with perspective that we are one people, on one world, beneath one sky. In paintings, in music, in words, the silence of space has never been empty. Humanity has filled it with meaning. The heavens are not simply a stage for science, but a canvas for imagination, a mirror for our emotions, a quiet companion through the long nights of history. Dreamers, perhaps this is why you listen now, not only to learn of stars and galaxies, but to feel their stillness, to let their calm draw you closer to rest. Science tells us what the stars are, but imagination tells us what they mean. And so, as we near the end of our journey, let us gather these threads, science, history, art, and wonder, into one final reflection. Dreamers, we have walked a long path together. We have traced the first fires of ancient stargazers, watched civilizations chart the heavens, followed telescopes into clarity, and seen rockets break the barrier between Earth and sky. We have heard how poets, artists, and musicians carried the stars into human hearts. And now, as our story draws to a close, let us return to where it all began. The silence. The silence of space is not the silence of absence. It is a silence of depth, of endlessness. A silence that humbles, yet comforts, reminding us how small we are, and yet how infinite our curiosity can be. Every star you see in the night sky is a message from the past. Its light traveling for years, centuries, sometimes millennia, to reach your eyes. To look upward is to look backward in time, receiving a gift of radiance from ages long gone. In this way, stargazing is not only science, but communion with history itself. And though we have filled the heavens with myths, music, and machines, the stars remain unchanged, quiet, steady, burning in their ancient rhythm. They wait patiently for us, offering wonder without demand. Dreamers, imagine now that you are lying beneath the dark, open sky. The air is still. Above you, countless stars glimmer like scattered lanterns, some bright, some faint, all silent. The Milky Way arcs across the heavens, a river of light flowing endlessly. For a moment, you let go of thought. You are no longer measuring, questioning, striving. You are simply present. In that stillness, the universe does not feel distant. It feels close, intimate, like a blanket drawn gently across your shoulders. You realize that the same silence filling space also fills you the pause between heartbeats, the breath held before sleep. This is why, perhaps, humans have always looked up, not only to understand the cosmos, but to understand themselves. The silence of space reflects the silence within. The vastness above mirrors the depth inside. As our journey ends, remember this: the stars will always be there, waiting, whether you are awake or dreaming. They shine for no reason other than to shine, and in their steady light, you may find peace, perspective, and rest. So, dreamers, let your eyes close. Let the silence carry you. Drift gently, as though you too are a traveler among the stars, floating in calm, endless night. And when morning comes, May you awaken with the same quiet wonder that has guided us through this story. The long silence of space remains eternal, patient, watching. And now, dreamer, it belongs to you too.